So 11.4 is called Math Induction. Math Induction is a way to prove things. In this section, we're basically going to prove that one side of an equation is the other side. Kind of like back in the trig days, we had to verify identities. You had to prove that one side is equal to the other side. Induction. So on the left side here, we've got a whole series. It's an arithmetic series. And when you add all of them up, you are going to get just n times 2n plus 1. This is the sum of all those terms. So in this case, n terms. So if I made n equal to 1, that means we have one term. So let's see if our formula works. By plugging 1 into the right side, I have 1 times 2 times 1 plus 1, which is 3 times 1, which is 3. If I add up all terms up to number 1, will I get 3? Yes, because I only have one term. But what if it was 2? 2 times 2 plus 1 equals 4 plus 1 is 5 times 2 is 10. Did it work for n equals 2? So it kind of looks like it doesn't because we get 7, but remember we're adding them all up. So we get 3 plus 7 is in fact 10. And we could go on and on and on. So it looks like it is a true statement. We can't prove anything by plugging in 1, 2, 3. Even if we did it 100 times, it's not a proof because 101 might not work. So using math induction, the first thing you need to do is figure out if 1 works. Okay? If 1 works, then we'll go from there. So in this case, plugging in 1, it did work, so we're going to assume it to be true. So first step you have to do is plug in 1 over here and see if it equals this term over here. You have to show your work for that. Track athletes leaving. Good luck, have fun. Okay, next step, and this is a complicated one, and it's going to take a couple examples. I'm going to take this one right here in terms of k, then I'm going to take this one here, in terms of k plus 1, I'm going to add those together. Gotta grab another flavor. Is equal to this one here in terms of k plus 1. So k plus 1 to k plus 1 plus 1. So we have three things. We have this one in terms of k, this one in terms of k plus 1 equals this one in terms of k plus 1. And if you want to just memorize that, that's just fine, not a bad way to do it. I can try to explain it, why that is the case. So let's say I've got, we assume this is to be true. So I've got this blue is equal to this blue. And then we're going to add one term to it. So we know it's true for one. We want to see if it's true for the next one. And I can't use n plus 1 because you can't use n in a proof if you're using n in the original. We haven't proven that it's true, so we have to use a different letter, which is, we'll just use k. So this is equal to that. We'll assume that. Now we're going to add one more term to it. So we'll add the k plus first term to it. So I added a little bit of red. Well, this right here is equal to all those added up, and I added a little bit of red to the left side, so now I'm going to add a little bit of red to the right side. Oops. There. So now I still have an equation. So what does all those represent? Well, this blue right here goes right here, and this blue plus red goes right here. and that, oh, I'm sorry, the k plus first term is the green, so I guess this would be your red and this is your blue. And that's equal to blue plus red. I don't know if that helped at all. So basically we added a little bit to both sides and we kept the equation true. I won't do blues, reds, all that stuff. That was my attempt to have you understand what all that is. Okay, and we'll do several examples today. Once we get to this point, and that's the most confusing point probably, now it's just algebra. We have to verify that the left side of the equation is equal to the right side. Think of it as a wall right down the middle. You can't like add one to each side. You can work on the left side, you can work on the right side, and see if it equals each other. So I'll give you a minute. Go ahead and do some algebra and see if you can get the left side equal to the right side. Then you're done with the problem. So 2k squared plus 5k plus 3 on the left. On the right side I've got 2k plus 2 plus 1. So I have a k plus 1 times 2k plus 3. So now we could either factor the left side or I could just FOIL the right side. I'm guessing, I think foiling is easier, so I get 2k squared plus 3k plus 2k plus 3, and then the last statement has to be identical. So this equals that, so we have proven using math induction. So what did we prove? We proved that when you add up all those terms, that arithmetic sequence, forever and ever, you can just, if you want to know the sum of them all, it's just n times 2n plus 1. All right, another example. So these are literally the problems from your notes. I'm not creative enough, or I didn't want to put the time in to find other ones. So I've got this 3n sequence here, and we're going to prove that it is equal to 3 halves n plus 1. So first thing you want to do is figure out when n is 1, does it make it true? I'll give you a second to try that. Plug in 1, see if you get 3 for an answer. All right, so it is true for 1. I think you'll find that every problem you can't solve, or you can't prove things without using math induction if this is not true. But you do need to show your work to indicate that it is true. Okay, so now this stuff in terms of k plus, that's in terms of k. This stuff equals this stuff in terms of k plus 1. So the first one is in terms of k, that comes from right there. Then this one in terms of k plus 1 equals that one in terms of k plus 1. And now we just have to verify the left side equal to the right side. I'll give you a couple minutes for that. Alright, so it's just algebra. Let's see. 3 halves k squared. I have a 3 halves k plus a 3k. So 3 halves k plus a 6 halves k gives me 9 halves k. And looks like if I just distribute this, I get 3 halves k squared plus 9 halves k plus 3. So it works out. How many got that to work out? Alright, only a couple people, but I probably didn't give you enough time. Now the baseball people are leaving. Good luck, have fun, go Spartans. Hope it doesn't rain on you as soon as you get there.
I hope so too.
Is it on grass or turf?
Dirt.
Dirt?
Yeah.
You'll be alright.
It rained this morning. I don't think it's supposed to rain.
Good. Alright. Last example. See if you can do start to finish. Alright, prove that using Math Induction if it ever comes into focus. Come on. Alright, so first thing we want to do is plug 1 in. 1 times 1 plus 4, 5 times 1 is 5, 5 equals 5, check mark. So now we'll do this one in terms of k, so k times k plus 4, plus this one in terms of k plus 1, 3 plus 2 times k plus 1 is equal to that one in terms of k plus 1. How many got that far? Good. So now we got to do stuff. Plus 4k plus 3 plus 2k plus 2, so I have a k squared plus 6k plus 5. Foil that out, I get a k squared plus 5k plus 1k, 6k plus 5. Bam. At least you know you did it right when the left side equals the right side. Hopefully you didn't make up stuff and get creative. But yeah, if you do everything right algebraically, they should be equal to each other and feeling good about your answer. How many got that to work out? Good. Questions?